Hi, welcome to AJ Tutoring's YouTube channel. I'm Steven, and we're going to be talking about AP Physics 1 rotational motion. And you can click here for tutoring and here for more content. Let's get into it. Today, I want to do one of my favorite calculations that you can do at a high school level of physics. It's really cool because it's a calculation you don't think you should be able to do at the high school level of physics, but you really can. And it's to calculate the orbital velocity of the International Space Station using just uniform circular motion and Newton's gravity. To put those two pieces together, so we start with Newton's gravitational equation and the centripetal acceleration from uniform circular motion. We can use uniform circular motion here because the International Space Station is going in a uniform circle orbiting Earth. So this equation applies. This equation, again, just comes from the geometrical properties of going in a uniform circle and the acceleration from that. So extending these two to each other is we do by simply saying that this is a force. So Newton's second law applies. It's the only force acting on the International Space Station here. So it's equal to ma, where the mass here is the mass of the International Space Station, and the acceleration here is the acceleration centripetal, since, again, it's going in uniform circular motion. So these two masses up here, one of them is going to be the mass of the International Space Station, and the other is going to be the mass of Earth, the mass at the center of this here. So we go ahead and say that, and then we can cancel the mass of the International Space Station and the International Space Station here, and we get that the acceleration centripetal is just going to be gm Earth over r squared. Remember, this acceleration is just this v squared over r here, so we end up with v squared over r gm Earth over r squared. These are the same r. It's the radius of Earth plus the orbiting altitude of the International Space Station. So we can cancel one of those, and then if we take the square root, technically we could do plus or minus because we could go in either direction. So we do the square root gm Earth over r, because again, we get one r to cancel. Now, that equation, I genuinely want you to do this. I want you to take these numbers. I want you to plug in g is equal to 6.674 times 10 to the negative 11th Newton meter squared per kilogram squared. These units just make this equation work out. The mass of Earth, which is 5.971, 10 to the 24th kilograms. 10 to the 24th is a lot. And then the radius of the Earth plus the orbit is 6,779,773 meters. If you do that, if you plug these into this, you will get that the velocity is 7,664.1 meters per second, which is not far off from the number given by NASA. If you enjoyed that video, be sure to like and subscribe. And if you need more help with tutoring, be sure to check out our website at ajtutoring.com or look at more content below.